The prospect of creating super soldiers such as that of Captain Steve Rogers here in the real world has been sought after by both governmental and private organizations for years. And while Steve Rogers is a staple of comic books and the MCU alike, how close are we here in our own world to creating real-life super soldiers? Stick with us today, watchers of the Marvel Multiverse, as we break down the leading real-world science behind the production of super soldiers, and explore just how close we are to producing groundbreaking genetic and technological advancements that could one day lead to a new breed of specialized soldiers right here in our own world. This will be our second installment of this series, as we explore the real-life inspirations for Marvel properties, characters, and subjects. Our previous video covering the real-life Red Room and Black Widow operatives. If you guys enjoyed this real-world look at Marvel properties, please hit that like button and comment down below what other things you would like to see explored. Now, let's get on with the video. Many of the advancements made in the name of pushing the limits of physical human capabilities have come from the private sector, rather than a directly government-backed project like the Strategic Scientific Reserve as seen in the first Captain America film. This is largely because the government stands to benefit from private contracts and purchasing off-the-shelf advancements rather than awarding grants and organizing its own projects. This allows the government to have the products delivered right to their doorstep instead of funding their own research projects, enhancing the speed of production and slashing the costs of investments. But what exactly are some of these projects that have been pursued with the idea of creating physically superior soldiers? The first of which we'll be discussing today is artificial blood. Yes, artificially engineered blood could be the first step in creating soldiers and athletes who are able to push their limits far beyond the expectations of a normal person, and the basis of such experiments are already in place. Robert Freitas, a leading nanotechnology engineer at the Institute of Molecular Manufacturing, has been the driving force behind the production of what is known as respirocytes. These artificial red blood cells behave very similarly to typical red blood cells without the limitations of human genetics that nature has thus far dictated. These respirocytes are a hypothetical enhancement that would be comprised of three distinct types of what are called rotors. The first type of rotor would be designed to absorb and release oxygen. The second would be to absorb and release carbon dioxide, and the third to absorb and release glucose. In essence, these respirocytes would behave the same way that typical red blood cells would, but their artificial creation would surpass anything that the nature-made red blood cells are capable of, allowing scientists to directly inject artificial blood enhancements into their subjects. Freitas hypothesizes that these respirocytes could allow an average human to be able to hold their breath at the bottom of a pool for 4 hours or more, or allow an athlete to sprint at their top speed for 15 straight minutes without the need to stop and breathe, mitigating muscle fatigue. This would allow soldiers to operate at high altitudes where the oxygen is significantly depleted to the same degree that they would on sea level. And the first steps in this artificial blood enhancement are already in place. The process known as blood doping is a controversial practice among some very high-level athletes, and it involves drawing a significant amount of a participant's blood in advance. Their body would then naturally regenerate the lost blood cells over time, only for the athlete in question to re-inject the blood they drew back into their system. This allows for an artificially enhanced red blood cell count, allowing their blood to carry more oxygen at a much more efficient degree, and thus allowing them to push their physical performance faster and longer than their competitors. They can pump more oxygen throughout their system, allowing them to push themselves harder than they would otherwise be able to. This improved endurance allows for a significant edge in most competitions, and could serve as the basis for what these respirocytes may be capable of. On top of these respirocytes and blood enhancement, strides in alteration of genetic code have also been made in recent years. Dr. Paul Zare, the director of the Center of Biomedical Research at the University of Victoria, is one of the leading experts in gene therapy and hormone modification, and has been extensively researching the use of different anabolic steroids and performance-enhancing compounds that closely resemble the super soldier serum that we see in the MCU. Dr. Zare has already used extensive hormone treatments and therapies, as well as genetic modification to treat, cure, and supplement patients with certain deficits or medical conditions. He proposes a reality in which these same modifications are used on already healthy individuals in order to push them past the limits of human physical capability. capability, and he points to practices found in various livestock as proof. A process is already in place that allows researchers to remove the myostatin gene from the Belgian blue cows. What this does is basically acts as a limiter for muscle production, and in turn, this allows the cows to produce above average amounts of muscle far beyond what should naturally be possible for the animal based on its genetic code. Basically, we're getting really jacked cows. Dr. Zare proposes that these types of treatments paired with a healthy human subject on a strict training regimen could result in a soldier that is up to 30% stronger than the strongest gym rats that humanity currently has to offer. And genetic modification has already made incredible strides in practice, and we still have more super soldier programs to go. The CRISPR gene editing process is a relatively new program that allows individuals to modify their genetic code. CRISPR uses what is known as vectors in order to deliver modified information to already healthy genes. This allows new genetic material to be added to the nuclei of existing cells to either replace, modify, or enhance the genetic material that is already active using what is known as transgenes. While this has widely been used to treat various genetic diseases by editing the damaged genes that are causing the disease, as technology develops, complete access to gene modification may become a possibility in the near future. But these various genetic and physical advancements are also supplemented by various technological advancements that can also be applied to these soldiers. Perhaps the most intriguing of which is, in essence, directly injecting night vision into a subject's eye. The University of Massachusetts Medical School in Worcester has been developing a system of converting infrared waves directly into visible light, and have already made promising advancements on live test subjects. The university technicians have already gotten to the point where they have successfully re-engineered the vision of mice to accommodate this new advancement. Mice that can completely see in the dark. They put the mice in a variety of mazes and trained them to solve the mazes as per usual. When they subjected the mice to a dark environment by turning the lights off, the mice predictably couldn't see. However, after their enhancement, the mice were able to navigate the mazes just as easily in low or no light conditions, the same as they were in typical daylight levels. Professor Xiaoyu Tian, one of the heads of the program, believes that it is only a matter of time before this kind of research is applicable to human subjects. Allowing soldiers to navigate low light areas with ease would do away with the need for various night vision goggles, which can cost anywhere up to $40,000 and only offer limited peripheral vision and focus. These clunky devices, however advanced, would then be deemed obsolete if this process becomes a mainstay in military practice. As it stands, the limits of human capability are constantly being pushed to the brink, and new developments to surpass the limits of the human body are being made every single day. With the rate that scientific advancements are being made in the worlds of genetics and military technology, it's only a matter of time before the governments and private sectors of the world have the capability to produce their own new breed of specialized super soldiers. But anyway, my friends, what do you think of all this scientific advancement? Do you think humans will soon have the ability to create artificially enhanced super soldiers? And more importantly, if we can do it, should we? What did you guys think about this second installment of the Real Life Marvel series? I hope you guys enjoyed, as a lot of time and research goes into these videos. If you did, please don't forget to hit that like button and share it with your friends who may find it interesting. As always guys, hit that subscribe button to assemble and join our team, and have a great day.